Hello everyone, I am Arham Noorine from Sri Venkateshwara College of Engineering, studying in second semester in the Department of Computer Science Cybersecurity. I am here with a presentation on mathematics, that is integral calculus, and we'll be learning about that and the basics of it. What is integral calculus? It is the branch of mathematics that deals with the concept of integration, which is essentially the reverse process of differentiation. It focuses on the study of integral and antiderivative functions. Integrations allows you to find the area under curves, compute accumulated quantities, and solve various problems related to the rate of change. The integral function represents the sign under the curve and the function within the specified interval. It is denoted with the S symbol and it is often used in variety of fields including physics, engineering, economics, and more to solve problems involving continuous quantities and rates of change. What is integral calculus? Well, it is the value of the function found by the process of integration. The process of getting f of x from f dash of x is called integration. That is how it is the reverse process of differentiation. Here, integrals assign the number to functions in a way that describe displacement and motion problems, area and volume problems, so on to arise combining all the small data. The given derivative f and the function of f which determines the function f. From f dash we get f, that is integration. Here we have an example. If the given f of x is x squared, the derivative of f of x, that is f dash of x, we derive f of x, it becomes f dash of x. So x squared becomes 2x. This 2x is denoted as g of x and the g of x is equal to 2x. Then antiderivative of g of x, when we integrate g of x, it will be again x squared. So integration of 2x will be x squared. We can say that with this example. F of x is called as the antiderivative of the primitive function of f of x on integral I. Integral is a representation of area under the curve. We represent the actual value of integral by drawing rectangles. The definite integral of a function can be represented as the area of the region bound with the graph of the given function between 2 points in the line. The area of the region is found by breaking into thin vertical rectangles by applying lower and upper limits, and the area of the region is summed up. See, if we have a curve and we have to find its area, in integration, what we do is we divide it into small rectangles and then we add up all the rectangles and we find the accurate area. Here, there are two types of integrals. There is definite and indefinite integrals. Indefinite integrals, these are the integrals that do not have a pre-existing value of limits, thus making the final value of integral indefinite. Here, integration of g dash of x becomes g of x plus c. Here, plus c is a constant which is added in indefinite integrals. Indefinite integrals belong to the family of parallel curves. Indefinite means the value is not assigned for integration. We mostly integrate from 0 to 1 or pi by 2 to minus pi by 2. Here, when no value is given, it becomes indefinite integrals. In a definite integral, we have a pre-existing value of limits, thus making the final value an integral and definite. If f of x is a function of a curve, here look, b is outside, so a f of x dx becomes f of b minus f of a. Here, if you observe the graph, if we have divided this into many rectangles, here there is one rectangle which we have. From A to B, we are integrating f of x, we are finding this space by integrating from A to B. Then we find the accurate area. This is definite integrals. We have different methods to find integrals. There are several methods adopting for finding indefinite integrals. The prominent methods are we finding integrals by integration by substitution method. Then we have integration by parts, and we also find it by integration of partial fractions. Here there is a quote on that supports integration. The power of integration lies in its ability to the bridge gap between discrete quantities and the continuous quantities, making it a powerful tool for solving real-world problems. Application of integration and integrals. We can find area under curves. Integration is used to calculate the area under the curve in a given interval. This has application in geometry, physics, and engineering. It has finding the area of irregular shape, calculating the work done, determining the total distance traveled. It is used in physics and engineering. Yes, in engineering we study about integrals in the first module itself. Quantities like displacement, velocity, acceleration can be found. Integrating velocity gives us displacement. Integrating acceleration gives us velocity. It is used in probability and statistics. It is helpful for us to find the cumulative distribution functions and also obtaining integrating PDFs. Economics, it is used in integration of economics to calculate consumer and producer surplus, the benefits of consumers and producers receive in a market transaction. It is also used in calculating present value and economic growth models. Integration is also used in computer graphics. It is used in rendering realistic images by stimulating behavior of light and calculating shading of surfaces. It is used in geography and cartography. It helps in calculating measures such as area, volume, curvature of geographical and topographical features. It is also used in fluid mechanics. Integration plays an important role in calculating fluid flow rates and pressures, forces, and fluid dynamics. This is how we found out that integration is very helpful. Thank you. Like, share, and subscribe to the channel.